Today we're going to look at charging objects and how we can actually get electrons to move from one object to another. And we're going to look in particular at charging by friction. So let's look at that. Objects, normally, when they're just hanging out, whatever, they are normal. Oh, how come this didn't work? Sorry. There we go. Objects are normally neutral overall. This means that the number of protons equals the number of electrons. So here are two objects. One is amber, that sort of yellow hard stone, and fur. And I've kind of drawn you some protons and electrons on each one to show you that they're always equal, meaning that they're neutral. So what we can do to actually make an object have a charge, we can do that three ways to charge an object. So we can charge it by friction, charge by contact, or charge by induction. Today we're going to focus just on charging by friction. The next video will talk about charging by contact, and then the last video will be charging by induction. So charging by friction, what is it? Hopefully you've heard of the word friction before. So basically what it is when two substances are rubbed together, it creates friction and they become charged. Remember what I said in the last video, though? We must remember that only electrons can move. Protons and neutrons never move. So if during this rubbing one substance is going to get charged, it's getting charged because the electrons are transferring from one object to another. So one object will have a stronger hold on electrons and pull them away from atoms in the other substance. So if we look at this little diagram at the bottom, before rubbing, both the amber and the fur are both neutral and they have equal number of positive and negative charges. When we rub them together, amber ends up having a stronger pull on the electrons than the fur does. So the electrons move from the fur to the amber. After that, the amber is going to have a negative charge, and the electrons moved away from the fur, and the fur is now going to have a positive charge. So just by rubbing these two substances together, we can move the electrons and create objects with a negative and a positive charge. Couple more points. The substance with the stronger hold on electrons will gain electrons. When you gain electrons, you gain negative charges, so you become negatively charged. The substance with the weaker hold on electrons will lose those electrons and become positively charged. So that's what I just talked about on the last diagram. So again, just to reiterate, amber is going to have a stronger hold on the electrons, grab onto the electrons from the fur, and become negatively charged. The fur has a weak hold on electrons, so those electrons are going to transfer over to the amber, leaving fur with a positive charge. So let's predict the charges that will build up on each object as they're rubbed together. So after rubbing, I guess we've already done this. So after rubbing, this is what the amber and the fur looks like. So where did the electrons go? They moved from the fur to the amber. And like I said before, the amber is now negatively charged and the fur is now positively charged. So you can copy that into your notes. All right, so I told you in this example that amber has a stronger hold on electrons than fur does. Great. How are you going to know which direction the electrons will move? How are you going to be able to figure that out? Well, if we look at this point here, we can determine which substance has a stronger hold on the electrons by using the Triboelectric Series, or also known as the electrostatic series. This is a list. Just check out this list for now of a bunch of different substances. And it can basically, you can use it to tell you which object has a stronger hold on electrons. This will always be given to you. So you do not have to memorize this list whatsoever. It's kind of like the periodic table in our last unit, okay? You have to know how to use it, but you don't have to memorize it. So how do you use it? Well, basically, it tells us which objects have a stronger hold on electrons. The ones at the top have a weak hold on electrons, and therefore they will lose electrons and become positively charged. The ones at the bottom have a strong hold on electrons. Therefore, they're going to gain the electrons from the other substance when they're rubbed together and become negatively charged. So basically, anything that's further down on the list will grab electrons from something that's further up on the list. So we're going to go through a couple of examples to make sure you guys can understand this, and then we'll also talk about it more in class. So the farther apart the two materials are on that list, the stronger the resulting charges. That's a really important point. So make sure you've got that highlighted or put a little star beside it in your notes. If the two materials are really far apart on that list, you're going to have a very strong static charge. If they're very close together, you can still have a static charge, but it will be weaker. So let's do some practice questions. Use that electrostatic series to predict the charge that will build up on each of the objects. So when a cat rubs its fur along a plastic bag, explain how the charges are produced and illustrate the transfer of electrons using a diagram. Use different colors to represent different substances. So what's actually going to happen here? So we're basically comparing fur and a plastic bag. So you guys can go back to your electrostatic series and find out where is fur, right here, cat's fur and human hair, and where's plastic. So based on this, plastic is closer to the bottom. That means when you compare fur and plastic together, fur has a stronger hold on the electrons compared to fur. Fur will have a weaker hold on electrons. So now that we know that, let's go back and see if we can answer this question. The cat's fur has a weaker hold, so the cat's fur will actually become positive. Why? Because it has a weak hold on the electrons. On its electrons. And it will easily give up those electrons to the plastic bag. The plastic bag, on the other hand, will become negatively charged. Or just negative, because it has a strong hold on the electrons and will grab them from the fur. So make sure you have that copied down. And then we're going to draw a diagram of this. So let's draw a diagram. So I'm going to draw the cat's fur because I wrote it on the last slide in blue. I'm going to draw, say this is the cat's fur, and this is the plastic. So I'm going to color code it so that you guys can see the difference, okay? So let's say the fur has, to start before rubbing, it has, we'll draw in 4 positive and 4 negative charges, and the plastic also has 4 positive and 4 negative charges. So right now they're both neutral, okay? After we rub them together and create that friction, what's going to happen? Here's the fur in blue, and we're going to have the plastic in red. So now they're touching and they're being rubbed together. What's going to happen? Well, we already said, if you look at the last slide, we already said that the cat's fur has a weak hold on its electrons. So that means that these electrons are going to get transferred to the plastic. So if I draw in my protons, okay, the fur might maybe keep 1 electron, but the other 3 will move over, say in this one here, moves over to the plastic, okay? So when I draw my plastic charges, still got my positive charges here, okay? And I also have my negative charges on the plastic, okay? But now I've gotten these extra negative charges from the fur, Okay, so now once they're separate, so if I draw another little arrow going down here, once they separate out again, here's the fur in blue, here's the plastic in red. Now the fur has 1, 2, 3, 4 positive charges, but only 1 negative charge left. So the fur's charge has a 3+ charge because there's 3 extra positive charges. The plastic, on the other hand, has 4 charges, but now it had 4 original charges, but then it gained 3 more charges. So now the charge on your plastic is 3- because it gained 3 extra electrons. Now in reality, when this happens, a lot more than just 3 electrons will move. I only drew 3. You could have drawn 2 moving, you could have drawn all 4 moving. Wouldn't really matter as long as you can show that some electrons are moving from the fur to the plastic. So that's all we're going to learn about today. We're going to do more examples of this in class, and we're actually going to do a lab where you actually get to rub these substances together and create a static charge. So we'll look at that together in class tomorrow.